Okay, welcome back to our videos. In this video, I'm going to be talking about defining your own MATLAB functions. So let's go ahead and just jump right in. I talked about scripts last time, so if you want to create a new function, you just come up, click New, and then Function. And what happens is it pulls up the editor, and it gives you this nice little template. So this is the basic anatomy of a function. You have to have this function keyword. All keywords in MATLAB are highlighted in blue in the editor. So it has to start with this keyword function. Then you define the output, what that function is going to return to you. You have to give it a name. The name can't start with a number, just like variables can't start with a number. And then you give it whatever input arguments you have here. So I'm going to go ahead and just define a function really quick to calculate the area of a circle. So I'm going to define the output of the function to be called circ area, and then I'm going to give it a name. The name of the function is going to be called circle, and the input to the function is going to be a variable called radius. Now this little section here is where we can type in some comments that describe what our function does. So I'm just going to write in this function calculates the area of a circle with radius equal to rad. With let's see here, let's add one more, and area equal to circ area. Alright. Now, all I have to do is I don't have to define radius because it's an input variable, so we're going to pass in a value for the radius. So I don't have to say up here radius equals something like 4. That would defeat the purpose of a function because a function allows us to pass in a value for the radius. I don't have to define it, but I do need to define the area of the circle in terms of that radius. So circ area is going to be equal to pi, which is a special variable in MATLAB set to the value of pi, times the radius squared. Alright, here's our simple function. I can save this. I can click on here and save. I'm going to save it on my desktop, and this is important. Functions, unlike scripts, have to be saved with the same name that you name the function. So I named this function circle, so its file that it's saved in needs to be named circle.m. So I save that. Now I can jump back to my command window and I can use that. So once again, I need to make sure that my my MATLAB instance here is pointed to the directory that has my code in it, and I can see here that right here it says I'm in home Joseph desktop. That's the folder that I'm in, or the directory I'm in, and I can see the circ.m. So I should be able to use it here. Just type in circle and then I think there's already a MATLAB function called circle. I wonder what's going to happen. Well, it's going to use ours. Alright, so actually what I should do is I should go back and change the name of my function because MATLAB already has a circle function. So I'm going to call this calc circle area, and now I'm going to do save as. I have to change the name to be the same as the name that I have, calc circle area. Save it. Alright, now let's go back to my command window, and now you can see I've got calc circle area here. I'm going to go ahead and just delete this. Can I delete it from here? Yes, I can. Okay, so now if I type in clear and calc circle area, just give it a radius. So I type in some value. I want to know the area of a circle of radius 4.5, and it returns the value of that circle. So I could use this function. I could to define the area of some circle. So maybe I create a variable to store the area. So I'm going to call it C for circle, A for area, and 1 for my first circle area. And that's going to be equal to calc circ area. I'll say 4.3 this time. And now you can see I have the CA1 variable that is storing this value as 58.080 for the area. I could also use this to calculate like the area of a ring. So a ring is, I can calculate the area of a ring by subtracting the area of a smaller circle from the area of a bigger circle. So I could call this function twice. Calc circ area, let's do a big circle, 5, minus calc circ area of one that's 3, and that'll give us the area of a ring that is 2 units thick. So 5 minus 2. Anyways, there's your area of the ring. So that's the very basics of a function. Let me show you how to do that. Let's create a new function. Well, gotta go back to our editor. Now, if I was gonna type this out on my own, I would type out function in the outputs, y equals, I'm going to just call this function x, and then open parentheses inputs, and then I have to have an end. And that's all the syntax that I need to define a function. I need to now put in the body of the function, so maybe I would define y in terms of x. So I'd say y equals x squared plus x minus 3, some polynomial. Now I can say this function f dot n, save it, and I can go back to my here and type in f of 5. Ta-da! Alright, so please try and follow along and write these functions that I've written too, so that you can get used to the MATLAB syntax. You'll also, one thing I want to point out in the function here, all keywords in MATLAB are always lowercase. So if I were to type capital F, see how it's not blue anymore? It's because it's no longer a MATLAB keyword. It has to be lowercase. Same with N. If I type capital E, it wouldn't work. Okay. Also, you can define other functions in the same function file and then use them inside here. So I could create another function y equals f1 of x, and so your input variables can be named anything as long as you use that same variable name. Look, I can put in Harry. That's going to be my variable name for the input variable. And then I could say, and this is my output variable. So maybe I can use anything for my output variable. Jane. Okay, that's my output variable. And now I could say Jane equals Harry cubed minus 35 semicolon. I think I explained the semicolon operator in the previous video. It just suppresses the output of this command. So if I didn't have this, MATLAB would spit out Jane equals whatever we passed in for Harry cubed minus 35, and then it would also return Jane as the function value. So anyways, I can save this, and then down here I could actually use my Jane function up here. I could say y equals x squared plus Jane of 4, or Jane of x. So now this is going to take an input variable x, and it's going to set y equal to x squared plus whatever my Jane function evaluated at that x value is as well. And so Jane will get whatever's passed in here, and it will say, okay, take that value, it's now called Harry in this function, not x, and cube it, subtract 35 from it, and return that value. It's not Jane. It's not Jane. This is supposed to be F1, sorry. F1. Jane is the return value, so return Jane. Alright. So let's save it and run it. F of 2 minus 23. So how did it get that? Let's go back to our function. It said, okay, take 2 squared and then add f1 of 2. F1 of 2, so f1 takes 2, it cubes it, which is 8, subtracts 35 from that. So 8 minus 35 is 27. So 27, so negative 27. So negative 27 plus 4 is negative 23, and that's what our value was. Right? Negative 23. So hopefully you can follow that and it makes sense. Alright, now so far everything we've done has been pretty simple. We haven't done anything that you really couldn't do in a spreadsheet. So let's do something a little bit more complicated. Let's look at this function right here. So here I've got a stress strain plot for some material. So we take some material and we pull on it upward and downward, and we keep pulling on it with more and more force. What happens is that material starts to elongate, and it does so in a linear way until it gets to a strain, which strain represents percent of elongation, essentially. And then at this point it starts to stretch out much more, and it does so in a non-linear way, and eventually it breaks. So that's why this just stops here. So this right here is a piecewise function of the stress in terms of the strain. Well, wouldn't it be nice if we could write a function that kind of captured this? And actually, typically, we are given values of the stress here for this stress where it starts to behave non-linearly. It's called the yield stress. It's denoted here by sigma y. And then sigma ultimate is the stress at which it breaks. So here, the conditions, the piecewise conditions for this function are given in terms of stress. So we should rewrite this to be actually a function of stress that predicts strain. So we can do that by we can do that by rewriting these equations such that the strain for this condition is equal to sigma divided by E. So I've just taken this equation for the first case and divided E over on the other side of the equal sign. Anyways, the fact of the matter is, though, for a function like this, we have to check conditions. We have to say, okay, if sigma divided by E is less than, no, if sigma is less than or equal to sigma y, then use this equation to generate the strain. If sigma is greater than sigma y but less than sigma ultimate, then check to see, then use this equation to calculate the strain. Otherwise, then we know that sigma is greater than the ultimate stress. Just tell us that the piece has fractured. So in order to do this, we need to use what's called conditional branching. And so in MATLAB, we have if statements and else if statements that allow us to do this, to check statements and then run code based on those whether those statements are true or false. So I'm going to go ahead and once again kind of show you how if statements work in MATLAB. So let's just say we have some condition is 5 greater than 7. Well, we see that 5 is greater than 7, so this should evaluate to true. So how do we represent true, which is what we call a Boolean value? How does MATLAB represent this? Well, if we just hit enter, sorry, 5 is not greater than 7, so it should evaluate to false. So the answer is 0. So 0 represents false. If I had flipped it around and changed this to a less than sign, then it would be true. And so a value of 1 actually represents true. So when you type this in and hit enter, it evaluates to to either 0 or 1, 0 representing false, 1 representing true. Just how if I had entered 2 plus 2, it's going to spit out 4. Okay? When you enter in a logical expression like this, it returns a number, 0 or 1. 0 being false, 1 being true. And so you can use if statements to evaluate, to make decisions based off of these logical expressions. So you can do any kind of expression. I could say 5 equal to 6. So I have to use double equal signs to check if 5 is equal to 6. Actually, it makes more sense if I use a variable. So let's define a variable x, set it equal to 5. Okay. Now over here we have a variable equal to 5. Now let's create another variable y, set that equal to 7. Okay. Now these variables are just placeholders. They just hold these values. This equal sign says assign the value 5 to this variable x. Assign this value 7 to this variable y. Now I can say is x greater than y? And it's going to say 0, which means false. Now I can say is y equal to x plus 2? Hey, yes it is, because 5 plus 2 just so happens to be 7. I couldn't say, if I said y just 1 equals x plus 2, it's actually going to say this equals means assignment. So it's going to assign y the value of x plus 2, which is still 7, but it's going to assign it. It's not going to check if it's true or false. So if it's going to be true or false, you have to use the double equal sign. Other logical expressions you can use are I could check two conditions at once. So I could say is x less than y, is x less than y, and y equal to x plus 2. Well, this is equal to, this evaluates to true because 5 is less than 7, and this evaluates to true. So then when I have two statements, true and true, should evaluate to true. So if one of them had been false, like x plus 3 now, then it's going to evaluate to 0 because condition 1 and condition 2 aren't true. In order for this expression to evaluate to true, both of these expressions would have to evaluate to true. Now you could use an OR logic instead. You could say evaluate two Boolean expressions, two logical expressions, and if one of them is true, then return true. So that's called OR logic. So I could say, is x less than y, which is true, or you use these two bars to do it. On my keyboard, it's you hold shift and then hit the backslash key twice. Anyways, x greater than y, and then I could do this y equal to x plus 3, which this is false. But because one of them is true, it's going to evaluate to true. So you can use OR logic. Now, there's all kinds of ways to compare Boolean expressions. You can use all these logical operators. You can do greater than, less than, equal to, not equal to, greater than or equal to, less than or equal to, the AND Boolean expression and the OR Boolean expression. You can put all of those next to an if statement. So let's do an if statement example now. So, I wanted to keep, let's reset that. X equals 5, y equals 7. Alright, so now I have those variables defined. Now, let's do an if statement. So now, let's say I have these variables and I want to change something about them. So I could say if I want my program that I'm writing to behave differently based on these values, I can use them. I can do that with if statements. I could say if x is greater than y, then run some commands. Set z equal to 5. And then I could say else set z equal to 7. Now I type end, hit enter. And now you see z was set equal to 7. So why was that? Let's go through. So it checked here. It says if x is greater than y, is that true or false? Well, x is 5 and y is 7. So this is false. So it said, hey, this is false, so don't set z equal to 5. Use the else statement and set z equal to 7. And then it ended. Now you could just use just a straight up if statement. You could say if x is less than y, set z equal to 2, and then end. So now it's just going to check. It's just going to check, and if it's false, it'll set. If it's true, it'll set z equal to 2. If not, it's not going to do anything. So hey, look, it set z equal to 2 because x is less than y. However, if I change it, if I say if x is greater than y, set z equal to 5, is this going to do anything to z? No, because it's false. So you see z stayed as 2 up here. Alright, now you can have your if statement check multiple conditions if you want. But the general syntax for if statements, I forgot else if. Let me explain else if. So if I want to check more than just 2 conditions, I can string these if-else statements together using the else-if keyword. So I've got x and y. So let's do one that checks two conditions and then has a third optional condition. That's kind of what we're shooting for with our stress-strain piecewise function. So let's say if x is greater than y, then set z equal to 4. Then we'll say else if, and we'll check another condition. If y is less than 5, well, let's do z. Let's keep it with x. If x is greater than something bigger than y, we'll do 12. Set z equal to 2. Else set z equal to 9. End. Alright. So what this is going to do, it's going to check if this condition is true, it's going to run this command. If it's not true, and then it'll be done. And I'll just jump straight to the end statement. However, if this is false, then it's going to come here and it's going to say check this condition and say, okay, is x greater than 12? If it's true, it's going to run this command and then be done. If it's false, then it's going to run this command. So let's go through and predict it before we run it. Is x greater than y? Well, x is 5, y is 7, so this is false, so it's not going to run this. It's now going to check this. Is x greater than 12? 5 is not greater than 12, so this is false. So it's actually going to run this. We should expect z to be set to a value of 9 after we run this. And ta-da, we see z is set to a value of 9. Okay, so let's go ahead and code up our little stress-strain function. So we're going to create a new function. Come over here. Let's create a new function. I'm going to title it strain. And I'm going to give it a sigma. And I'm going to call this calc strain like this. And I'm going to have it return a variable called strain. Okay? So in our function, we had some parameters. These parameters that we needed to set, the Young's modulus, that's here, this k value, n value, sigma y, and sigma ultimate. So I'm going to go ahead and set those values, define some variables, and set them equal to these values. So let's go ahead and say E is what I'll define Young's modulus, capital E. MATLAB is case sensitive, so E was equal to 3,750 megapascals. There's no units in MATLAB, so you can use comments to denote units, megapascals. K equal to 640. This is also megapascals. N we'll set equal to 0.3. Sigma y is set to 300. This is also in megapascals. And sigma ultimate is equal to 520 megapascals. Alright, now we've got those variables set, they're defined. Now we want to implement this function, except for we're going to calculate strain, which is epsilon, from sigma. Okay, so the first thing we want to check is if sigma is less than sigma y, we want to calculate it using this equation right here. Okay, So we'll just check that. If sigma is our input variable right here, that's what's going to be put in. So that's what we're using. If sigma is less than or equal to sigma y, then set the strain, that's our output variable, equal to sigma divided by e. All I did was I solved for strain in this equation right here by dividing this e over on the other side of sigma. Okay, now else, do I have another condition that I want to check next. My condition here is I now want to check if sigma is less than sigma ultimate. Okay, so else if sigma is less than sigma ultimate, then if that's true, I want to set the strain equal to, let's see here, solving this next nonlinear equation is less simple, but what we get just using algebra is sigma divided by k raised to the 1 divided by n. Go ahead and check that algebra. And then else, if it's not, then we know that the material is fractured. So what we can do actually is we can set the strain variable, which is our output variable, equal to a string, which is just a bunch of characters or a word. So I'm just going to say fractured like this. So when the way that you set variables equal to strings like this is you just enclose your string of characters inside single quotes. Okay? And then I need the end statement to end this if else if clause here. Okay? Alright, now my function is done. It should work. So we should be able to test this. If we give it a value of sigma less than 300, it should show up in this linear region. These should be aligned down here. I don't know why they're not. And so we should use this equation, and then we should be able to get a value. If we use a value between 300 and 520, then it should use this equation. And ideally, we would compute, we'd know some exact values, and we'd check to make sure our function gave us the exact right values. But we can check for sure if it's fractured by punching in a stress greater than what was it, 520, and then it should spit out fractured as a result. So let's go ahead and try that. So save this. I'm going to save it as calcstrain.m on my desktop. I'm going to come back in here in MATLAB, and I'm going to type in calc strain. I'm going to give it a sigma value, and let's give it a value of 200. Should spit out, there's our value for strain, 0.0533. It's a unitless number. Now if I put in a value above 500, like a 520, it should give fractured. So let's try 600. If I put in 600, then hey, it returns, hey, it fractured. It's too high of stress for this material. It's beyond the ultimate stress. Alright, that is kind of what I'm going to cover in this video. We've covered functions, the anatomy of a function. You should know how to create a function, what keywords you have to type in. You need to define your input variables. It's got to have a name. It's got to have a defined output variable. In the body of the function, you have to set the output variable equal to something. And it has to have the end keyword. And then you can use conditional branching structures, control structures, to build complicated programs. Alright, we will talk more about other control structures such as loops, and then in the next video, and arrays. We'll do some examples. So we will see you next time.